Okay, good afternoon, everyone. Thanks for attending today. Today's topic is going to be vertical coordinate systems and their transformations in Geographic Calculator 2014. So let's actually get rolling into the meat and potatoes of today. We're going to be talking about vertical transformations and vertical coordinate systems within Geographic Calculator 2014, and of note, I am using Service Pack 1 today. We rolled out Service Pack 1 several weeks ago now. A lot of folks have started using it. We're starting to get some feedback that folks are liking some of the enhancements that came out. We streamlined a few things in there. One thing I do want to draw attention to is if you are a heavy user of vertical transformations and you do have Calculator 2014, definitely grab the service pack for this. We have made a couple of enhancements that sort of add some flexibility to some of the types of transformations we can do. We had a couple of kinks that we worked out, really opened up the flexibility of some of the different transformations that we can string together now in 2014 Service Pack 1. So what we're going to be talking about today are specifically the vertical aspects of coordinate systems. And where we're going to be looking are in some particular places around the interface of the Geographic Calculator. We're going to be looking here on the interactive job. This is where I'm going to set up a few different examples, but I just want to point out where these things pop up, because the vertical coordinate systems are not all throughout the calculator. They're on a number of the jobs, but they are focused to some very particular tasks. So here on the interactive job, you can see I have some extra height fields in addition to our normal latitude and longitude or northing and easting fields. So we can work in 2D or 3D in a number of places, and where we're going to be able to work in 3D, you will see a vertical box added to the coordinate systems. At the bottom of the coordinate system control is where you're going to find that vertical system. So the vertical system basically gives us the up and down to the main system's two-dimensional side-to-side, if you will. There are a few different types of systems that we're going to be talking about today. We're mostly going to be talking about vertical models that are what are called geoid-based vertical models. We're going to get into the nuts and bolts of the definitions here. There are a few different kinds, and these do pop up a few different ways. So we're going to look at some of the nuance in there on a few different interfaces. We're going to climb into the data source itself and take a look at some of the parameters and how things have changed over, particularly from 2013 to the 2014 release of the Geographic Calculator. And we're going to take a look at how these things are selected and applied. So to kick things off here, over in the Project Manager, you're going to see a few predefined jobs. And this is for anybody who's attended my webinars. You're probably familiar with my Roadshow workspace over here, where I have examples of just about everything you can do with the calculator. Within the project folder that's at the very top up there, these are the base templates of jobs. So those are what you see out of the box, and everything beneath that are specialty things that I've set up in my workspace and saved in place as templates. So the places we're going to be taking a look today where vertical coordinate systems pop in. Interactive conversions, where we are right now on the main screen for single coordinate conversions and transformations. Point database conversions, you'll notice the vertical fields enabled down there at the bottom. Point database for all of our tabular data sets. Seismic survey conversions, also for tabular data sets, but very specifically focused on some seismic data formats, things like SEG-P1, UCOA P190, SPS, SEG-Y, some of these various seismic specialty data types. Vector data conversions, here's where we're talking about things like shape files, AutoCAD files, LiDAR data, can be 2D, 3D, doesn't really matter. Same vertical boxes that we're going to see down at the bottom there. And then we're going to jump down to the raster transformation job. That is normally a two-dimensional job, but we're going to take a look at the case of this job that lights up the 3D capabilities when we're not just talking about raster imagery, but when we're talking about terrain-based rasters or raster grids that define elevations. We're going to start by taking a look under the data source menu, and we're going to take a look at some of the nuts and bolts of how these coordinate systems have actually changed with this release, because there is a little bit of an adaptation that folks who are used to working with the Geographic Calculator in previous versions, there's some changes to how these are organized. So we're going to take a look under Data Source up here. And on the Data Source menu, you'll see this list. If you're familiar with the 2013 release and most of the releases back from the Blue Marble desktop names, you're going to notice this list has actually gotten shorter over the years. And that's not because we do fewer things in the calculator than we used to. It's that they're organized a little bit differently. We've changed some of the models, particularly to align better with standards like the EPSG database. So under the Data Source menu, folks that work with vertical systems may remember down at the bottom of this first section here, there would be a list of vertical datums, a list called vertical references, and another group called height models. All of these same ideas are still here in the calculator. They're just simply broken out slightly different ways. We don't have the height model category anymore. The height model has changed over to be what we call a vertical transformation, and we'll now actually find that under the coordinate transformation definitions chunk. The vertical reference itself, those are more analogous to what is now called a vertical coordinate system, and the vertical datums are now found under datum definitions. Seems like some obvious stuff. What actually happened here is we realigned our model to better line up with the EPSG database. Makes it much easier to find a one-to-one definition when you're trying to cross-reference something from the Geographic Calculator's database to something like the EPSG or something else that is based on the EPSG for transformations. So the first thing we're going to take a look at here is datum definitions. Under datum definitions, this used to only have the horizontal datums. So you'll notice there's two categories now, and vertical datums is one of those. So under vertical datums, we have all of the various systems that we see in the calculator. At this point, well over 100 different vertical datums used all over the world for different regions. The interesting thing of the vertical datums is if we grab onto any one of those, and I'm just going to grab onto the Black Sea datum completely at random, when we view the information for those, you'll notice the definition panel for those is actually blank. The vertical datums don't have any of their own defining information. It is simply a name, and the name gives us all we need to know to match that up against something else. So the Black Sea is the vertical datum name. Has an EPSG code. It may be associated with other software that we would see under the identifiers, but really the vertical datum is just the common thing that we agree on. We say this is the vertical datum we are all working on, and we then get there through transformations. So interesting little nuance. There are no parameters to define a vertical datum. Somewhat similar to how things used to be, presented slightly different way in there. So that's the vertical datum. If we take a look down under coordinate transformations, this is where we have seen what used to be called a height model migrate off to. I'm going to take a look down under single transformations. These are also found under concatenated transformations. I'm going to look at single transformations just to keep things simple here. But you'll notice under the single transformations, we have the different categories. Our regular datum transformations, those are for our horizontal datums, parametric transformations that might go between different types of coordinate systems, and our vertical transformations. So again, under the vertical transformations, you'll see all of the various transformations between the different vertical coordinate systems. So these are analogous to the height models that we used to have. These are actually the real meat and potatoes of a vertical transformation. The geoids, the offsets, all of these things are the transformation itself. Recently, we've been getting a lot of folks asking, what's the difference between a geoid and a transformation? Why isn't the geoid actually a coordinate system? Why is it a transformation? And the reason for this, let me see if I can find a good example a little farther down in the list. Actually, New Zealand provides us a pretty good example in here. You'll see all of these various transformations for different parts of the same grid. Or a little farther down in the various US models. All of these transformations are different geoids, so the geoid is actually the transformation that transforms from ellipsoid height. So if we take a look at the source of all of these, we're going from WGS84 to the target of NAVD88, a North American vertical datum of 1988. Same source, same target, but a different geoid for getting to that target. So from ellipsoid height, the geoid provides the offset to get us to the sea level model of those systems. Or in the case of the VDatum tidal models, from the regional datum to the same standard datum in the middle. Different grids, different surfaces going between the same name for input and output on those. That's why these are actually transformations rather than the coordinate systems themselves. You're probably noticing a lot of these are in red. The red transformations are indicating that they are not presently usable, and those are typically going to be for models under the type. You'll see various geoid models listed off in there. We don't ship all of these out of the box. A lot of these are for very, very specialty use in little pockets of the world. The way these work, if you want to enable one of these transformations that you see in the list that you don't have the grids for, is you simply right-click on those definitions and you'll see download missing files. That automatically reaches out via an FTP connection to our website where we host as many of these geoids as we can, automatically grabs onto those grids, downloads them to your local machine. For those of you on the technical end of this, it places them in the data path that you will find in the preferences. So you do need write access to your data path in the user preferences to download these files. But once you have those grids, they are instantly enabled for use. All of these grids that we have on our FTP site for automatic download are free of charge. You can access any of those for no additional cost. The reason we have this secondary download is because these geoids can be quite large. In some cases, such as the EGM 2008 grid, you're looking at a file that's actually an extra gigabyte, which is 5 times larger than the software is itself. So that's why we don't have them all out of the box. Most folks only need to use 1 or 2 of these, and we let you pick the ones you need and keep our footprint rather small. So those are the transformations. And again, for those of you coming forward from previous versions, these are more analogous to what used to be called a height model in the old versions. And lastly, under the data source menu here, we're going to take a look at the coordinate system definitions. This is where we actually define the vertical coordinate system that we're going to be selecting on the interfaces where we deal with these. So under coordinate systems, again, you'll see all the main categories. Our fitted engineering systems, our geocentric systems, which are 3D Cartesian, our geodetic systems, which are 2D lat long, 2D or 3D lat long, projected systems, things like transverse Mercator and so on, string-based coordinate systems for some of the specialty coordinate formatting, and then our vertical systems. So the vertical systems are unique in that all of the vertical systems, they simply provide us the up and down for the horizontal systems. So the vertical systems are all grouped and categorized geopolitically, just like all of the rest of the horizontal coordinate systems. If we crack down into any of the subfolders, we'll see any of the models that apply throughout that whole area. For instance, if we grab onto North America, we'll see IGLD 85, a model that's used in large regions of North America. If we go down under United States, you'll see just those systems that are used within the smaller bounding area. Now the vertical coordinate system, if we crack those open, and view the parameters, you'll see they actually have some fairly minimal parameters. They're very similar to the amount of parameters that you see in a latitude-longitude coordinate system. So they are defined by the datum, and that is the vertical datum. So if you remember, the vertical datum was the object we just looked at that had no parameters. It simply gives us the standardized name that is used for the base vertical datum in that system. And then they have an area of use, which defines where on the planet they're used, and a point style. And the point style simply defines for us the units that are used in that system. So whether we're talking about meters or something like US feet or international feet, in the cases of depths, we might be talking about fathoms, things like that. But very minimal sets of parameters to define a vertical coordinate system. The main part of the definition that is really used to relate different systems, again, comes with that transformation for how we get from one vertical coordinate system to another vertical coordinate system. And again, all the same identification information where you may have remarks, you may have identifiers linking up these parameters to various databases. So now that we've taken a look at some of the definitions in here, what these are called, where they're found, let's put this into practice on the interface. So we're going to take a fairly quick look. This is really a somewhat simple topic once we've got the nuts and bolts down. We're going to start out here on the interactive job, and we're going to take a look at our usual example of NAD27 to WGS84. Normally we use this for selecting just simply a two-dimensional transformation, but today we're going to be adding on an extra piece. We're going to be adding on the vertical component, and we're going to be specifically adding on the NGVD29, that's the North American North American Geoidal Vertical Datum of 1929, I believe is what that stands for. And we're going to transform that over to simply ellipsoid height. So we're going to do both a horizontal and a vertical transformation in here, so two steps. In the past, what would happen is we would select our horizontal system on input and output, and we would select what was called at the time a vertical reference. Now we're going to select a vertical coordinate system, and the main difference between the old and the new is that the vertical reference actually had a vertical transformation attached to it. So there would be a geoid model attached to that NGVD29. The transformation was actually part of the name. So for folks that are used to working in some of the older releases, you would see things like NGVD29 via geoid like 94 or 96, various geoid names that we would see in there. For another common one here in North America, you would see NAVD88 via geoid 12A or something like that. Now those transformations, just like the horizontal transformations, are compartmentalized into their own selection. So we're going to select the vertical coordinate system. So we're grabbing onto our NGVD29 height. We attach that to the horizontal. So we have the side-to-side coming from NAD27. The vertical is provided by the NGVD29. The selection of that vertical is going to light up an extra field here. It's called gravity-related height because that comes from a geoid model. And we can simply apply whatever the elevation is that is recorded against that source system. So on the output side here, I'm going to do a horizontal and a vertical transformation here. So we're going to take our horizontal transformation over to WGS84. On the vertical side of that, I'm going to do a transformation here that will put this into what I call GPS-friendly coordinates. So we're going to go from an older geoid to ellipsoid height based on WGS84. The ellipsoid height, in particular, it is a world system. It's used anywhere on the planet, so you will find that under the world category. It is not defined by any parameters other than the ellipsoid height of the system you're dealing with. So we're going to grab onto ellipsoid height over there. And our usual sample coordinate locating us off in the trees somewhere here in Maine nearby where we are. And just for a nice simple example, I'm going to say this is 1 foot of elevation for our transformation. We're going to select our coordinate transformation in the middle, and what we're going to see is a two-step process here. The first transformation it's going to look for is going to relate NAD27 to WGS84 on the horizontal sense, and then we're going to be doing a second step that we select the vertical transformation. So let's go ahead and double click on our coordinate transformation box here and see this in action. What comes up is the list of geographically appropriate transformations for the combinations of systems that we've put in. So the first step here is to select our horizontal system, and this is just like normal selecting a horizontal transformation. So I'm going to grab on to the transformation pair that works best for our area here. I'm going to double click on that. You can also simply single select and then click next down in the lower right, and this will then hop us onto the second transformation. And you'll notice the systems there are a little bit different. They are mentioning the vertical components, and it's actually stringing two transformations together in order to get us from the source to the target systems. The accuracies, you'll notice, are actually blanked out for these. Accuracy ratings are not often given for a lot of the geoid models. We will be filling those out as we research and find some more of these. For now, those accuracies are simply unrated to the standards that we usually follow. And you'll find various geoids. This is where the number of different geoids pop up. So again, in the past, when you select that vertical datum, you would see things like NGVD29 via a certain geoid model. That geoid model is now what we're selecting directly here. So we've selected our system, and this step selects the transformations for us. So to get us from our input of NGVD29 to an output of ellipsoid height on WGS84, we actually need to do a couple of things. The first transformation will relate NGVD29 to NAVD88, which is really the only thing NGVD29 can get itself to on ellipsoid height, and then it will apply a geoid transformation from NAVD88. It's going to use the various geoid models here that we need to select from to relate that back down to the base ellipsoid that they come from. So in this case, we're going to see a transformation from NGVD29 to NAVD88, and then a secondary step of one of the particular geoids that relates a geoid height here in North America back to the base ellipsoid height. So what I'm going to grab onto here is my US geoid model of 2012A, our current standard around the country. I could select any of these, depending on what year we might have been working in previously. And again, we're seeing some of those red options in there. If we did want to use any of those, again, all we have to do is right-click and say download missing files, and then they would be instantly available once the download completes. So I'm going to grab on to our NGVD29 to NAVD88 and US geoid model of 2012 to connect all the dots through there, and I'm going to say OK. Now when it returns us back to the main interface, you're going to see four transformations at work here. The first two are going to be our horizontal transformations. That's the two-step transformation I picked at the very beginning. And then the second two that we're going to see in there are going to be the vertical transformations. So it's going to grab all of those together in a series of steps in between the middle, and it's going to relate those from the start to the finish, and it's actually doing four transformations in there on the way from the source to the target. And then finally, after all of those selections, we hit calculate, and we get out our final coordinates. So we have the horizontal coordinates that are changed and the vertical coordinate that is changed. So we'll see at this particular point, we are well below the ellipsoid. In this case, the ellipsoid is quite a bit over our heads around a lot of area here in Maine. So that is the new general process for making these transformations. We're going to take a quick look at some of the other jobs around the interface. Before we step off onto some of the other cases of this, I'm going to take a look at some of the questions. We've had a couple of questions coming in, and we'll see if any of those are stuff we can take on the fly here. First of all, let's see here. Do the special features come with 2014? I assume what you're talking about are the special features folder that I have here in my project. That folder is the short answer is yes. There's really two answers. The short answer is yes, you can do all of these things with Calculator 2014, but the long answer is you don't need those objects in those folders. I created those. Those are simply templates that I have with examples of all of the different types of data. So just a very quick example down here, you'll see the jobs that I have named things like seg-y, layer splitting, LiDAR, DEM. All of these are simply cases of the first 8 types of jobs, interactive conversions, point database conversions, that I've already set up with specific types of data, specific coordinate systems. Really, they're things that you can do in any workspace. So all of those features are nothing new. They're things that you've been able to do for quite a long time in the calculator. It's just showing specialty data sets in there for examples. Let's see here. Another question about are there EPSG codes that have only vertical datums? I'm not entirely sure quite what you mean by that. There are, let me just pull up the vertical datums list in there under datum definitions. Under vertical datums, you'll notice that there are EPSG codes assigned to most of those vertical datums. Those are direct lookups for the EPSG. You can match those up. The vertical datums have an EPSG code, as well as the vertical coordinate systems have an EPSG code, and all the transformations have EPSG codes. Part of realigning the model that we use was specifically to better line up with the EPSG codes, but you will see a few in there that do not have an EPSG code. Those are things that have not been added to the EPSG database, things that we've either implemented custom for certain folks based on publicly available data or so on. So much like all of the rest of the database, the majority of it comes from the EPSG, but there are a number of things that are not in the EPSG as well. If that's not quite what you were asking, please feel free to follow up, and I'll do my best to give you a more meaningful answer if that's not what you were asking. Another question on why the change to gravity-related height. Previously, those were called orthometric height on the labels. This was another thing that came from the realignment to the EPSG model. All of the point styles that we have on the coordinate systems, so where we select, let's see here, where we select our coordinate systems, the point styles give us that definition. So the gravity-related height is specifically something that is labeled by the EPSG database standards. If we crack into any of those, you'll see there is a label for those, and the label comes from that point style. If you'd like a different label in there, you can actually define custom versions of these systems that have a different label applied to those. So you are free to control those. Out of the box, they do relate to gravity-related height. Some of them have different values in there as well. Those labels simply come in from the point styles. So let's move on to some of the other topics here. We're not going to step through an example here on the point database job. I just simply want to point out where these settings apply. You'll notice down at the bottom of the coordinate system settings, the vertical box is enabled just like it is on the interactive job. Where the settings in particular come into play on the point database conversions are under the column settings. Once you have turned on a vertical reference, you will see a elevation field light up just like you do on the interactive job for selecting from a drop-down of all of those column names. So on my stock default system here of WGS84, you'll notice I don't have that vertical field lit up. However, if I do simply grab onto any vertical reference, I'm just going to grab onto ellipsoid height here for a quick example. When we go to pick those column settings, then you get the extra column selection for those z values that you would have, whether those are projected z values, whether they're going to be lat-long z-values, or if we're going to mix in Earth-centered, Earth-fixed style coordinates, geocentric coordinates, we're going to see those as well. So point database conversions, seismic survey conversions, both of those happen the same exact way. The vertical coordinate systems are lit up in there. If you grab onto the vertical definition, it's automatically going to be applied with either the column selection on the point database conversion or on the seismic survey conversions. We know where those vertical fields live, and those get applied directly. On the vector data conversion, very similar process here. Not much is different between the process on vector data conversion or interactive conversion or point database conversion. We simply grab on to the elevations that we have. As we load in the various coordinates that we have, I'm just going to reopen my shapefile here. As we load in the shapefile, it's going to automatically set the coordinate system for us. And in this case, my shapefile defines its horizontal system, but it doesn't define its vertical system. If you have a PRJ attached to these that do define the vertical system, or if you have other types of data, things like LiDAR, that actually carries its coordinate system information with it, those will load up the appropriate vertical coordinate system on the way in. So in this case, if we were going to be loading up our contours, what I have here is simply a vector file of contours that were analyzed from the common ASTER global terrain data set. Those elevations are all based on the EGM96 geoid. So I would select my EGM96 geoid height for our input. On the output side, let's say I wanted to make this, again, simply GPS friendly. I would select our ellipsoid height, and again, we double click in the center to first select our horizontal transformation and then our vertical transformation. So WGS84 ellipsoid heights to EGM96 geoid heights. We could get in there, take a look at the transformation parameters, make sure we're using the appropriate grid files for that transformation if we are familiar with all of that. Then the transformation happens exactly like it does on the interactive job. We process that data, and it does both the horizontal and the vertical transformation in one step for the 3D data. There's not a lot to see on that particular operation. Essentially, the elevations that are native to that vector file are going to be transformed from one reference to the other reference. In the case of things like shape files, the Z's are buried right in the vertexes. AutoCAD files, LiDAR files, all of the same types of process applies in there. The elevation just simply goes right along with the vertical. The one we're going to wrap up with here is I'm going to take a quick look at DEM files, so digital elevation models. There's a little bit more to the interface here with a digital elevation model. On these, this is a raster grid of elevations, so not a conventional image type, but the vertical coordinate system handling happens just the same way. Now this is simply a special case of our normal raster transformation job. So just for example, I'm going to click back over there to the raster transform job. This is where we're going to see our normal 2D raster interfaces. You're going to see that there's not a vertical coordinate system box lit up with our coordinate system controls because normal imagery is 2D. There is no elevation stored with it. When we load up a raster transformation job and the data type is a digital elevation model type, and there are a few different types we support in there, when it is one of those types that's detected being loaded in, you'll see the interface change over to the second style that I've just brought back up on screen. You'll see the vertical coordinate system boxes light back up on both input and output, and as well you're going to see a new button here that controls the shading options for actually rendering that information in the viewer and here on the thumbnail of the job to preview that data. So the input coordinate system, again, loads in from the data if it is present. The vertical reference would simply need to be set, and in this case, the vertical model I would need to grab onto for this data would be NavD88, and, excuse me, not NavD88, I meant NGVD29. This is NAD27 based data. So I simply apply the vertical reference just the same way as I do for the other jobs. On the output sides of this, same thing. We simply grab onto whatever transformation, or rather whatever vertical coordinate system we want to put this onto, whether it's something like EGM 2008, EGM 96, or a nice basic ellipsoid height, and then the transformation happens exactly the same way. I'm not going to bother going through the transformation here. We're going to keep this one fairly quick. I am simply going to point out how the shading options work, because this is really the only other place where vertical data has a different way to handle how we see it on screen. We have this shader that is enabled for the DEM type specifically, because this is the only other type of data that needs to have some sort of appearance put with it in order for it to look like anything on screen. So whenever the DEM data is loaded up in here, you'll notice on the raster job, the configure shader button lights up, and as well on the viewer that we'll be taking a look at in just a second, the viewer is going to have a similar group of settings to allow us to render the elevations in that DEM file. Now we have a number of predefined gradients that we have, and we can simply pick any of these out of the list, and those are going to apply different ranges of colors from low to high throughout whatever the ranges of data happen to be. Now these colors are not going to be maintained for output if you are writing out to a DEM type. So the digital elevation models, they only store the elevations. They don't actually store any of the colors. And there are a couple of things you can do here on the raster transform job with these transformations of the vertical coordinates. One is you can write it back out as an elevation model. So you can perform whatever type of geoid transformation you'd like to see, and then that will be reflected in the elevations that come with the output data. The other way we can go through here is you can actually flatten this into a two-dimensional raster image using the colors from the shader. So within the shader, there are these various options for changing the appearance, things like smooth coloring or stepped coloring that you'll see will render solid bins of elevation ranges on the data. There are things like hill shading that will either put shadows, virtual shadows on the data or not. Hill shading helps give a sense of depth to the human eye as you're looking at a 2D version of a 3D data set. And then there are various settings here for controlling that virtual light source, and then clipping the elevation ranges here as well. So if you want to only chop out a portion of elevations from your data, those settings at the very bottom are for that. All of those settings in the shader are what we use. What I've just done is double-clicked on the thumbnail up in the upper right corner. It's asking me where I want to open this data in the viewer. So I'm going to open this up in a new map just so we can see what we're looking at here. So again, all of these colors are simply being applied to the raster DEM for visualization in the viewer. Similar behavior if you're going to be loading LiDAR data into the viewer. It is a 2D viewer, and so it applies these shading options to the source that we have. In this case, it's our DEM. You'll notice in the lower right-hand corner, the elevation legend is available in the viewer. All of those shading options are available from the Customize button on that elevation legend as well. And we can do any of those different things like applying stepped coloring, taking away the shadows, and so on. That's just sort of one extra little extension. This is really the only place where we have a chance to do something other than transform the coordinates from one system to the other on this DEM type of imagery. All of these features are sort of new. That we've simply streamlined the way transformations happen. from either picking the transformations to applying the shading on elevation models and so on. Any of the folks that are with us today that are also global mapper users, you will be using the same type of process if you are using the Geographic Calculator extension into Global Mapper for enabling those three-dimensional transformations as well. So when we put in GeoCalc mode over in Global Mapper, we have all of these same tools for grabbing onto the horizontal transformations as well as the vertical transformations. So I'm just going to open it up here and see if we have any more questions that have come in. I'm flying solo here today, so bear with me for just a second while I try to read down through some of the transformations. Let's see here. Kind of a comment. You may want to clarify that vertical transform takes into account both the difference in the vertical datums, typically a very small difference in mean sea level, and the ellipsoid transform, which is the major component of the elevation difference. So that is a good point. On most of our geoid models, they are all mean sea level based. We do have a couple of options in there, particularly for users of vertical data around the coastal regions of the continental United States that are not mean sea level based. But most of these geoidal transformations, the differences that we see having multiple geoids in a single area are basically reworkings of some of those controls. Sometimes it's control that has been taken over a period of years, but these are all approximating small differences between mean sea level and the ellipsoid heights. That's why we see things like multiple geoids throughout the North American region. Some of those other places around the world will actually see multiple geoids. Australia, in particular, is another continent that has multiple geoids, all trying to approximate these small differences between mean sea level and ellipsoid transformations. Let's see here. One question on a particular transformation. EPSG code 5133 is a vertical datum. Off the top of my head, I don't exactly know which one that happens to be. I'm going to suggest you follow up with us at our tech support address, geohelp@bluemarblegeo.com. Many of the things that you'll see that are EPSG codes, many of these might be new. They could be out of sync if you're looking at other sources for trying to work with vertical datums. There's a lot of these coming online from the EPSG code. It may simply be that that particular system was one of the newer systems. But if you're looking for that in both ours and another place, I would recommend touching base with our tech support team. Let's see here. A question on what specific DEM formats we have. For that one, let me just actually go back to our interface for DEMs, and I'll just bring up the file types filter that we have. Down at the bottom of the raster file types, you'll see here the section from ArcInfo ASCII grid down. Those are all of the various types we have. So ArcInfo ASCII grids, the binary grids as well, the common DTED formats, that's a sort of common US military format, then the USGS formats, DEM, the SDTS DEM, which is the DDF extension, and the ASCII DEM, which is sometimes a little more common, which is a .dem extension, and then lastly the SRTM type, which has an extension of HGT. In the question there, the gentleman asking the question, I see you mentioned a couple of other types there that you're curious about, particularly GeoTIFF, TIFF and GeoTIFF, and IMG. Those formats are horizontal formats only in the transformer, particularly TIFF and GeoTIFF. We have occasionally considered adding TIFF to the elevation types. If you are commonly working with those, I would suggest that you maybe check out Global Mapper. our desktop GIS application. There are a number of additional types of elevation grids that are supported over in there. And if you're looking for particular models, file format models rather, you may have better luck in there, because we do actually support about 60 different types of raster elevation grids. Question on where the webinar will be posted after the fact here. So our webinars are all posted right on our website. So the page that you go to for registering for the webinar, at the top of that page, you will actually see a link to previous webinars. Once we do a little bit of video cleanup and audio cleanup to our video, well, we'll post it on YouTube, and it will be embedded right there on our webpage. You can also subscribe to our YouTube feed, and that will automatically notify you as soon as that video hits the web. Usually takes us a couple of days to get the videos cleaned up, and just for reference, if anybody's looking for last month's videos, they are live on our YouTube site. We had a little bit of trouble getting the video files processed. They will be posted very, very soon, but they are actually on our YouTube site right now. I think that is going to pretty much wrap it up for what we're doing today. Let's see here. Oh, one more quick question I'll take here on the VDatum integration. We will actually be talking about VDatum integration. Those are the U.S. tidal models. They're very slightly different from the normal vertical coordinate systems, but we will actually be addressing that in our next Geographic Calculator webinar. The next calculator webinar is going to be a feature overview of 2014, addressing some of the new features. One of the features we will be stopping on in there is the addition of the VDatum systems. We actually added those last year in Service Pack 1 of 2013. A lot of folks are new to it in 2014 as well, though, so we will be very quickly talking about that. That is just about all the time we've got today. I just want to close out with one last slide here. Thank you, everyone, for attending. Again, if you asked a question and I happened to miss it, or if you need a sort of a more technical answer for anything that we talked about today, please feel free to contact our tech support team at geohelp@bluemarblegeo.com. If you are a Global Mapper user, or if you're not a Global Mapper user and you want to learn a little bit more about that, our next session is going to be coming up on the 24th of the month, same time slot. That topic is going to be Global Mapper 15.2, and it's going to be a whole hour-long session focused on using the digitizer. All of our various drawing and vector feature editing tools, probably some of the basic analysis tools in there as well. So thank you very much, everyone, for attending today, and we will see you next time.